All right, our goal today is to learn the properties of angles. So what is an angle? Can you picture what an angle is? Can you visualize what it looks like? Okay. Now the definition might look a little bit funky because it's probably not what definition, or it's probably not the definition that you've used for angles in the past, but this is the proper geometry definition of an angle, and it is formed by two rays that have a common endpoint. So we're going to draw that. So start by drawing a ray. You can use your protractor as a straight edge. So we're going to draw a ray. We have an endpoint on one end. It goes in the opposite direction. Okay. And then we're going to draw a second ray that has a common endpoint. So it has the same endpoint, and it's just going to go in a different direction as the other ray. So it looks something like this. So that's an example of what an angle is going to look like. Now, there are different ways we can name an angle. Okay, so let's actually put some points on these rays. So we can maybe call this A. Maybe this will be C. Maybe this will be B. And maybe there was a number in here, just like that. And we're going to talk about the different ways that we can actually name this angle. One thing to know is that the common point, that common endpoint, this is what we call the vertex. That should be a familiar term. You guys use that term in Algebra 1. When you were graphing those V graphs, the absolute value graphs, that point was called a vertex, right? Or did you guys graph parabolas last year, those U-shaped graphs ever? Okay, and that turning point was the vertex. So the vertex is where it's like the turning point of the angle. It's the point of the angle. That vertex is a term that we'll use pretty often this year. So that right there is your vertex. So there are different ways to name this. One of the ways that I could name this, I could name it angle A. Okay. Now the reason I can name an angle A is because that's a vertex. Now that's just an angle symbol. It's kind of just like a little mini angle that you draw, and that's how you have to name it. You cannot just name it A without that sign right there. What is it if I just wrote A like this? That's a point. Very good. So I can't forget about that angle symbol because then it knows that I'm talking about the angle, okay, not a point. But it's named by that point on the vertex, okay, then I know I'm talking about this angle. The other way I can name it, or actually let me show you, the other symbol that sometimes people use, they'll put like a little arc through the angle. That's the exact same symbol. I don't usually put the arc there. You can if you want. It's just an extra mark you have to make in my mind, so I usually just put the little angle. The other way you can name it is you can name it by a number. So if there is a number in there, you can name it with the number. Right? The number is not always going to be there, so if it's not there, you can't use that method. But in this case, it's there, so we'll call this angle 2. There's another way you can use the points on the angle, And you'd have to use 3 of them. Now, sometimes this is our only option due to where the angle is placed. So I'll show you a couple of those examples in a little bit. But for right now, the way that you would name it is you trace it. So if you trace the angle, you go through C to A and then to B. You could name it angle CAB. If you traced it the opposite way, you would go from B to A to C. Either of those would be acceptable. So you can name an angle with 3 letters. Either of those would be acceptable. But the important thing to remember is that your vertex has to show up in the middle. Do you see that? It doesn't matter if you trace it from starting at B in this direction or starting at C in this direction. Either way, A has to be in that middle. In order to measure an angle, we will use a protractor. That is this tool that we just showed you, that we just handed out, that we also used as a straight edge. So to find the angle measure, you're going to use a protractor. I once had a student come in and they said, "Mrs. Fox, what do you get when you mix Fowlerville with geometry?" He goes, "Protractor. Get it?" And he came up with it on his own. I thought it was pretty clever. All right, so we use a protractor. To identify the angle measure, we measure it in degrees. And then when we write it, we would say the measure, so we use an M to denote the measure of angle A, and then I'm going to actually show you how you'd measure this. Right now, my numbers are backwards, so I don't really like looking at numbers backwards, so I'm going to flip this over so that I can actually read my numbers. Okay. See how I can read like 90, 100, 110? So put yours flat so you can read your numbers. And then I want all eyes on the board so you can first watch, and then I'll walk you through it with you guys doing it too. Okay, so I'm going to look for where the 0 is. And it doesn't matter if you use the inside numbers or the outside numbers. I typically like to use the outside numbers because, well, they have all those extra little lines on them, so I think it's easier to read. So your 0 has to line up with one of your rays on your angle. This point right here has to line up with your vertex. Okay, so I want my 0, that line, to line up with my angle. So now that I have this 0 line right on top of that angle, that point is right on top of my vertex. Now I can see where this ray, or the second ray, is hitting. Now sometimes if they are not long enough, you may have to use your straight edge, and you'll have to extend the rays on our angle so you can see where they actually hit on your protractor. So again, take your protractor. Now you guys can do this with me. Line up the 0 on one of your rays. Pull that point to the vertex. When your vertex is on that point, when the 0 is on one of your rays, we can see that it counts from 0, 10, 20, 30, 40, 50, 60. Mine is going to be different than yours. We just freehand drew these angles. So mine's at about 65, 66 degrees. So I'm going to write the measure of angle A equals 66 degrees. Now yours is going to be different than mine. Okay, it depends on how open your angle is. Okay, the wider your angle is.
Have your attention, good. Please.
Okay, so depending on how wide your angle is, if it's open wider, you're going to have a larger measure. The smaller it's opened, okay, the closer these rays come together, that means you're going to have a smaller number of a degree for the measure, okay? What would happen if you opened it all the way up to like a flat line? It's what? 180, very good. Okay, so it's 180 degrees if it becomes all the way all the way open to a flat line, okay? So these next three terms, these should look familiar to you. And we're just going to freehand draw them, but we'll make them look the best we can. A right angle looks like a corner. I'm just going to be full of jokes today. I'm going to tell you that if you ever tell me that you're cold in here, I'll tell you to go stand in the corner because it's always 90 degrees in the corner. I know, I'm just so full of jokes today, right? Okay, so a right angle is going to look like this. It's going to be a 90-degree angle. It looks like a corner. Oh, you can't even see what I'm writing. There we go. You guys got to warn me about that. I do it all the time. I apologize. Now, this next part might be new, okay? If we draw something like this, we cannot guarantee that it is a right angle or a 90-degree angle until it is marked as a right angle. And the mark for a right angle is a small box in the corner of it. That is a 90-degree angle mark. So if you see that in a diagram, then you can assume that it is 90 degrees or a right angle. But if that mark is not there, then do not assume, because assuming in geometry means bad news. Okay, so no assuming. But if it's marked, you're golden. Okay? An acute angle is a cute little angle. Okay? So it's the one that has to be less than 90 degrees. That says less than 90 degrees, in case you don't remember what that symbol means. Okay. So I'm going to make an angle that looks like it's open less than 90 degrees. An obtuse angle is one that is greater than 90 degrees. Now this one is actually has to be less than 180 degrees though. We want it to be between 90 and 180 degrees. So we would write it like this. X is bigger than 90, but X is smaller than 180, and we'll write it out. So it is greater than 90 degrees and less than 180 degrees. So we'll make this one look like it's opened up wider than 90, but not all the way to a straight line, because then things get messy. So there would be an obtuse angle. And then a good way to remember acute is just remember a cute little angle. Because aren't all little things cute? A cute little angle. That's how I always remember it. If you have a different way, or if you think that's weird and you don't want to think about that, then don't think about it, but you still have to know it. Okay? All right, so a straight line measures, so we talked about this, 180 degrees. And we call this a straight angle. So let's draw what that looks like. If you just draw a line and then add the vertex, then you know that you created a straight angle. The angle addition postulate is going to be very similar to what we did when we were doing the segment addition postulate. And all it means is, well, let me give you an example first. I'm going to draw an angle over here, and then we'll actually define the segment addition postulate. let's say I have an angle like this, but it's split into two parts. And I tell you that this angle here is 37 degrees.
Okay, can we have 12th graders?
Okay, so if this angle was marked 37 degrees and this one was marked 64 degrees, and I said, what would the entire angle have as a measure? What's that? Oh, I thought you pointed to something over here. I was so confused. Yes, you would just have to add the two together to figure out the entire measure. So the whole angle would be 101 degrees. Okay, so that's what the angle postulate says. And we did this with the segment addition postulate. All it says is that if you take the part plus another part, it equals the whole thing. Part plus part equals whole. So in this diagram over here, based on the angle addition postulate, we know the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle, and the way that we have to name the whole angle has to be, we cannot name it angle O. This is where I was saying that sometimes we have to resort to using the 3 letters. There are actually 3 different angles you could be talking about if you named this angle O, and that's why you're not allowed to name it just O. We would have to name it angle AOC, so we know we're talking about that whole angle. Now 1 is labeled on the inside, so we know it's this smaller angle. 2 is on this one, so we know it's this smaller angle. And this part together is the whole thing, so I'm talking about angle AOC. I could also name it angle COA. It doesn't matter as long as O is in between A and C. Are you with me on that? Does that look okay? And we have some examples of those on the back that we'll get to eventually. Vertical angles, there's a lot of vocab in this section. Vertical angles are angles that are formed by, they're opposite of each other. So they're opposite angles that are formed by 2 intersecting lines. So our examples on vertical angles would be the angles that are across from each other. So 1 is across from 3. So our example is angle 1 and angle 3 are vertical angles. And we often abbreviate these VA. So you'll probably want to write that down. And you'll want to be able to soon recognize VA means vertical angles. Okay. Another example would be what? Raise your hand if you can tell me another example. If 1 and 3 are vertical angles, give me another example. Go ahead. What is it? 2 and 4, very good. So angle 2 and angle 4 are vertical angles. Adjacent angles. Does anyone recognize that word adjacent? What does adjacent mean? Anyone know what adjacent means? What's that? You've heard the word, you still remember? Okay. It means next to. It means touching. Okay, so if we're talking about adjacent angles, we're talking about 2 angles that are touching one another. So they're going to share a ray. Okay, so these are going to be 2 angles that share a ray and vertex, because adjacent means next to. They have to be next to each other. So in our diagram off to the right, numbers 5 and 6 These are adjacent angles because this ray in between them is their common ray they share, and they have the same vertex. Okay. There are more examples between these two diagrams. Up here, 1 and 2 are also adjacent angles. And vertical angles and adjacent angles are pairs. You're only ever going to be talking about 2 of them. Okay, so 2 angles that are vertical angles, 2 angles that are adjacent angles. Okay, never 3, never 4, never 1, always 2. It's a pair. So you might be asked, what pair of angles are vertical angles, or what pair are adjacent? Okay. What's another example from this diagram up here? Angle 3 and angle 4. What's another example from up there? We wrote 1 and 2 already. What is it? 1 and 4 would work. Yep, 1 and 4. And the only one that we did not name yet, 2 and 3. How are we doing so far? Am I throwing a lot of information at you?
Retention.
All right, so flipping it over to the back side. These next 2 terms are terms that we use. This is also going to be a pair of angles. So a pair of angles would be complementary angles, and they're angles that add up to 90 degrees. And the way that I remember this, I think C and I think corner, and corners are 90 degrees. So that's my thought process. Complementary, corner, 90, and I know that the pair has to add up to 90 degrees. Supplementary, I look at the S and I think of the word straight, and good thing I can't even write that, straight. There we go. I think straight, and a straight angle is 180, so if I need a pair of supplementary angles, that means the angles have to add up to 180 degrees. All right. Now, sometimes when we're talking about complementary angles, they may or may not be adjacent. All right. So, for example, maybe you have an angle here and another angle here, and I tell you that this angle is 70 degrees and this angle is 20 degrees. These 2 angles are complementary angles because when you add 70 and 20, you get 90 degrees. Okay, so these 2 angles are complementary. The other thing is sometimes they're adjacent. So maybe they looked like this. Maybe this was marked 90, and then it was broken up into 2. Those angles are also complementary because I can see that the whole angle is 90. So part plus part equals whole, and the whole is 90. So either of these would be examples of, put a comma there so we can see that's an example or that's an example. So there's different ways to see what complementary looks like. Okay. And the same idea with supplementary angles as well. All right, so there are a couple things that we need to talk about that you can conclude from a diagram. Remember how I said that in geometry you cannot assume because bad things happen? Okay, so what are 3 things that you can conclude from a diagram? If you can see that 2 angles share a ray, that they are adjacent, if you can see that in a diagram, you know that they're adjacent. If you can see that 2 angles share a ray, you can automatically assume, yes, they are adjacent. That is okay. Okay. Another thing that you can look at a diagram and know it's true is if 2 angles are vertical angles. And remember, we often abbreviate that VA, so you'll want to make sure you recognize that abbreviation. The last thing that we can conclude from a diagram is a linear pair. Now that's a new word, so we're going to drop down here and actually define it. Okay. A linear pair is a pair of angles, so obviously there has to be two of them. So it's a pair of adjacent, supplementary, angles. Okay, so they're adjacent, meaning they share a ray, and supplementary. That means they have to add up to what? 180. So if you have two angles that share a ray, so they're right next to each other and they add up to 180, what's that angle going to look like? What's it going to look like? Anyone, can you picture it? If you have two angles next to each other and they added up to 180, what's a 180 degree angle look like? A straight line. So when we go to draw a linear pair, draw a straight angle like this, and then let's draw in that common ray that they share. It doesn't matter where you put that, because you have two angles there, and those two angles form a linear pair. Angles 1 and 2 form a linear pair. Because you can see that they're next to each other, right? See how they're touching, they share that common ray, and you can see that they form a straight line. That's something that when you look at a diagram, you can assume is true, okay? You can conclude that this is a linear pair from a diagram. So these are your big three things. You can conclude when angles are next to each other, you can conclude when they're across from each other, and you can conclude when they are a linear pair, so when they're next to each other and form that straight line. Okay? All right, so then the things that we cannot conclude that are sometimes they look like they might be true and you want to assume them. Okay, so as I was saying, so some things that people will want to conclude from a diagram, they'll look at it and they'll say, oh, those angles look the same, okay? But never assume that two angles or segments, for that matter, are congruent. So things that we do not want to assume, we'll put them in red because red's like bad, don't assume red, are that angles or segments are congruent, okay? Unless they're marked. Okay, so remember what congruent marks look like? They're little dashes on a segment. They're usually marked as arcs on an angle. So I'll show you what those look like when we get down a little bit further. Okay. The other thing that people want to assume when they're looking at a diagram, but you cannot assume because it's not a good thing when you assume, is that angles are right angles. They'll look at it and they'll say, well, that looks like it's like a right angle. Well, you can't assume that unless it has that little box in there. Okay, so if there's no box, do not assume that it's a right angle. And I'll do some abbreviating there. Our right angles. So we often will abbreviate right as RT, angles with the angle symbol. You also cannot look at lines and assume that they are parallel. Or perpendicular. Okay. Now the two symbols that these are, that's a parallel symbol. there's a perpendicular symbol. So I wanted to show you those because those are symbols that we'll use very often. So the upside down T, it looks like two lines that are perpendicular. That's your perpendicular symbol. These two, they look like slanted L's. They look parallel. That means parallel. Okay? So you cannot assume that lines are parallel. Perpendicular, do we remember what perpendicular means? Show me with your arms what perpendicular means. There you go. So they create like a 90 degree angles, right? Okay, so perpendicular means that they form 90 degree angles. Parallel, show me with your arms what parallel mean. Very good. So they run along next to each other, but they never touch, and they are coplanar. Okay. Right angles, we know what those look like. They look like perpendicular because perpendicular form right angles. And segments that are congruent when they look like they're the same size, or angles that look like they're the same size. We cannot assume these things unless they're actually marked in our diagram. Okay. An angle bisector, this is a new definition. Okay. An angle bisector is going to be a ray that cuts an angle in half. Okay? If you have a ray that cuts an angle in half, then that means that you'll have a part equals a part. Okay, so this was kind of like the segment, the 1.3. When you had a midpoint, it cuts the segment in half. An angle bisector cuts an angle in half. Okay, so that means each part are going to be the same size. Each part will be congruent or the same size. Okay. All right, so looking at this diagram, I'm going to look at it, I'm going to say, I do not know if that's a 90 degree angle because I have no 90 degree angle marked.
Seniors, Emma, Drew.
Okay, so I don't know if anything's congruent. I don't know that anything is 90. I do know that these angles are right next to each other. I know that they're adjacent angles because they share this ray. That I can assume from this diagram. I don't have any vertical angles. Nothing forms a line, so there's no linear pairs. I'm just kind of going through these two descriptions and saying what can I look at and say is true about this diagram. Okay, so that's just what I'm saying. Since I know that these are adjacent, I know that this part plus this part must be the entire thing. Okay? Because what I'm given here, and I will label it, the measure of angle EBF is this angle here. And the measure of angle FBG, is that angle there. And the measure of angle EBG is the entire angle. Can you see that? So it gives me this part, it gives me that part, and it gives me the whole thing. So since I don't know if anything is the same here, but I do know that the angle addition postulate says that part plus part equals whole, I can go to setting that up. The angle addition postulate always works when we're talking about adjacent angles. So I am going to take and I'm going to set this part plus the green part has to equal the whole thing. So I'm just going to fill in what I'm given, and then we'll go about solving it. So this part was 5x plus 3, plus the green part is 6x minus 4, equals the whole thing is 65. So I'm going to take that expression on the left and I'm going to simplify it, meaning I'm going to combine like terms. 5x and 6x is 11x. 3 and negative 4 is minus 1.
reminder.
So now that I have 11x minus 1 equals 65, I'm trying to get 11x by itself. So I have to get rid of all the other terms, like that minus 1. And in order to get rid of that, what I'm going to have to do is add 1 on both sides. (11x equals 66). I will then have to divide by 11 on both sides. And x equals 6. That's your first goal, is to figure out what is x. And then we have to go back and say, okay, the measure of angle EBF is represented by 5x plus 3. So I need to actually plug 6 into that. So 5 times 6 plus 3 is equal to, that's 30, plus 3 more is 33. So I can mark it down here that the measure of angle EBF is 33 degrees. Since I'm talking about the measure of an angle, I have to put the degree symbol. Otherwise, I'm actually giving it in radians, which we're not going to get into radians this year, but it's kind of a different unit, and that we don't want to talk about radians. So degrees, you have to put your degree symbol. All right, the measure of angle FBG is 6 times 6 minus 4, because x was 6. So 36 minus 4 is 32. Oh, wait. Aren't those supposed to be the same thing? Were those supposed to be the same number? No. But what do I know about those two angles? What do I know about the orange angle and the green angle? They don't necessarily have to be the same, but what has to happen about them? They have to add up to the whole angle, which they told me that the measure of angle EBG, which is the whole thing, they already told me that that was 65 degrees. Does 33 and 32 add to 65 degrees? Then that's my important part, okay? And on your unit test, there are questions that look like this, and one of the answers that I had to come up with was actually already given to me. So make sure that those match, okay? And that'll happen probably next week on your test, where you'll have to come up with an answer that was already given to you. It's just a matter of paying close attention, and you should automatically be able to get that point. All right. Over here, let's read this one. It says BF, ray BF, is the bisector of angle EBG. Let's see what angle I'm talking about. Angle EBG, here's to keep things the same. Here's the whole angle it's talking about. And it says that BF is a bisector. So this ray is a bisector of the angle. What does it mean if it's a bisector? Yes, it cuts it in half. Okay? So if a bisector cuts angle in half, if BF is cutting this large angle in half, what is something that we know? That it's equal on both sides, or congruent on both sides. So what you would do is you would mark these angles congruent. Those are angle congruent marks, okay? It'll have the same arcs in them. Sometimes they'll each have a single arc. Sometimes they'll both have a double arc. Sometimes they put dashes in their arcs. So if they have matching arc marks, that's kind of fun to say, then those are congruent marks, okay? So this time, I know that, let's see here, it talks about angle EBF, and it talks about angle FBG. Okay, well, what do you know? What did we mark about the yellow angle and the green angle? We marked them congruent, right? So in this case, I know that if I marked them congruent, then their measures must be equal. So part has to equal part in this case, because they were marked equal. or congruent in the diagram. So in this case, I'm going to have 3x plus 20. I'm going to have 3x plus 20 equal to 6x minus 4. Now in this case, you have x's on both sides, so you're going to want to move them all to one side. So I would move the 3x, because I like to deal with positive numbers, so that's the smaller one. So my 3x's go away over here. I'm going to have 20 equals 6x minus 3x is just 3x's left, minus 4. Now it looks like something similar that we had over here. So we're trying to get that x term alone, so we're going to have to add 4 to both sides. We're going to get 24 equals 3x. Still working on getting that x alone, so it's being multiplied by 3 right now, so we'll divide by 3 on both sides. And we're going to have x equals 8. Okay, so am I done? Nope. What am I going to have to do? Plug in that 8 to the angles. So for this angle, I know that I have 3 times 8 plus 20. So 24 and 20, 44. So, and the measure of angle EBF is 44. Remember, don't forget your degree symbol. Let's plug it in on this one. 6 times 8 minus 4. That's 48 minus 4 is 44. Are those supposed to be the same? Yeah, that's what we did. We set them equal to each other. Okay, so they should be the same. They both should be 44 degrees. Cool, we got it. Okay, well, wait a minute. It's asking for EBF. Or I'm sorry, EBG. Measure of angle EBG, that's the whole angle. But they didn't give me that, so I can't find that one, right? Yeah, I just have to add the parts together. Because even though I didn't have to use angle addition postulate to do any kind of setup here, I can still use angle addition postulate to figure out what the whole angle is. So 44 is part, 44 is part. So together, the whole angle has to be 88 degrees. Does that look okay?